chord also. Yes. So suppose guys, what do I want to find out? I want to find out the deviation angle through a prism. So suppose this is a prism which we have, and this is the base of that prism. This is angle A, which is called as the angle of prism, right? And let us assume that a light ray is incident at an angle. And let me change the color. Let's say here. Okay, this is your incident ray. It goes like this, and then it comes out like this. You know? This will be my emergent ray, and this will be my incident ray. This will be my refracted ray, right? If I try to draw the normals at different points, this is one of the normal, and this is another one of the normal, right? Yes or no? This angle is angle of incidence. This is R1. This is R2. This angle is E, and we already did all the equations and all, right? We already know the Snell's law, and we already know A is basically equals to what? R1 plus R2, right? Now, what is the deviation angle which I'm talking about? Can you see over here? If I produce this incident ray in the forward direction, if I produce this incident ray in the forward direction, so will this be the original path of the incident ray? Yes or no? If there was no prism, then this would have been the path of the incident ray, right? You just extend this incident ray in the forward direction. And can you see over here, if you if you do this in the backward direction, can you see this angle? Or basically this angle, to be short. So can you see guys, the light ray deviated by certain angle. This angle is called as the deviation angle. Deviation angle is basically the angle between the incident ray and the emergent ray. So this is what delta is. Okay. Now we need to find out what is the value of this delta. Okay. Is it clear, guys? Do we need to ये समझ में आया कि what do we need to find out, guys?
Yes, sir.
So we already know that angle A is basically equals to R1 plus R2, and we already know this by Snell's law. 1 into sine I is equals to mu into sine R1, and similarly 1 into sine E is equals to mu into sine R2. So we already know these three equations which will be governing everything, right? So now, can everyone see a triangle? Let me just take this much part. I just want only this much part. Control C and Control V, and let me zoom in. So guys, can you see over here? This was the point where the normal was falling. So let's say this point is D. This is the point where it is intersecting E. This is F. I'll draw this properly, don't worry. And let's say this is G. Okay. So can you see over here, there are two triangles, one rhombus, whatever you want to say. Right? Can you see these triangles, guys? Was this angle R1 and was this angle R2? Yes or no? Yes or no, guys? And can you see, guys, over here, this GF line was basically from here to here, right? GF. So can you see, this is basically the emergent ray. So this GF is basically the emergent ray. And can you see, guys, this light ray, which is going from D to G? And can you see, this was basically the incident ray, right? So can I say this angle is basically the deviation angle? Yes or no? एक बार फिर से देख लो. This is D, this is G, this is E, this is F. And can you see G to F is basically a part of emergent ray, D to G is basically a part of incident ray. So D to G is incident ray, G to F is emergent ray, although it's produced, but still. Can you see this was the angle of deviation, right? Yes or no? Yes or no, guys? इतना clear है?
Yes, sir.
Now, tell me this particular thing. If this angle is R1, this angle is R2, then what will be this angle? You remember this angle, the complete angle was basically I. एक बार once more. Let me draw the diagram again so that it will be much clear to you. I'll draw the diagram again, don't worry. Now is it making sense, guys? Guys, is it making sense now?
Yes, sir.
This angle is delta. This is I. This is R1. This is R2. This I named as E. And this I'm naming as G. So can you see over here? This angle is I. Acha, sorry. This angle is also E, right? So every angle has been defined now. Now see this clearly over here, guys. Can you see this line and this line had an angle I between them, so hence this whole angle will also be I. Similarly, this line and this line had an angle E between them, then that applies. This whole angle will be also E. If this is I, this is E, this much is R1 and this much is R2. So can you tell me what will be this much? Will this be
I
I
I
minus
minus?
minus
R1.
R1.
So that is what I wanted. And this will be E minus R2. Is it clear? So
Yes,
now
sir.
in triangle BGF, whatever it is, this angle is basically the delta which we need to find out. This is basically I minus R1 and this is basically E minus R1. So can you see over here, if this is delta, then what will be this angle? Will this be pi minus delta? Yes or no?
Yes, sir.
And from this triangle, can I write pi minus delta plus I minus R1 plus E minus R2? This is R2 is equals to what? Pi only, 180. The sum of the three angles of a triangle is basically this. So can you see from here, pi and pi will get cancelled, delta will move to that side, so delta will be equals to I minus R1 plus E minus R2. It can be proven directly with this something called as exterior angle theorem, but वो जाने दो, मैंने उसको ज़्यादा complicate नहीं किया. So this is I plus E minus common R1 plus R2, right? Can I write it like this equation? So from here, can you see this delta is basically I plus E, and what is R1 plus R2?
A.
A.
So delta is basically this, or you can remember it like this. It's up to you. It's up to you. Whichever you want. Generally, people use this, right? Is it clear? So basically, this is the
Yes,
formula
sir.
for delta.
So how did we get R1 plus R2 equals to A?
Because in the last class we did beta, the derivation. Remember?
Okay, yeah, fine. Sorry.
So this is the formula for the deviation angle. Is it clear? Is it clear, guys? Now, can you see, guys? Can I write this thing as? Do you remember by Snell's law? Uh, do you remember these equations by Snell's law? 1 into sine E is equals to mu into sine R2. Can I write E is equals to sine inverse of mu into sine into R2? So by Snell's law, we know this particular thing already. 1 into sin E is equals to ये लिखना नहीं है. Don't write this. Mu into sin R1. Can I write E is basically equals to what? E is basically equals to what? Tell me.
Sine inverse of
Sine
mu
inverse
sine
of
R1.
mu into sine of R1. Can I write sine of A minus R2? Don't write this, है ना guys? So A minus R2, right? And from here, can you see over here? I can write E as what? What can I write E? Or from here, delta will be equals to I plus A. Oh, sorry, I minus A plus E, which is sine inverse of mu of sine of A minus R1. A minus R1, right? What did you write? Sorry, my bad. So, anyways, I can write this R1 also from this particular equation, right? R1 also just like inverse of I, right? So I can write this thing as sine. The whole function becomes something like this: sine inverse of sine of I divided by mu. ऐसा कुछ. So can you see there is a very ganda sa function of delta, but can you see this is I, which is constant. I is basically the angle of incidence. A is basically what? A constant, and mu is also a constant. So can you see here delta is represented as a function of angle of incidence, right? If I can represent delta as a function of incidence, then there will be a graph also for this. Yes or no?
Yes, sir.
So later on we'll do a graph on this. That this is not there in your syllabus, but the graph is. So later on we'll plot a graph between delta and I, and we'll see different things. Is this clear? Is it clear, guys? Hello.
Yes, sir.
Yes, sir.
Now there are certain conditions for different things in case of prism. First, let's talk about condition of grazing emergence. So depending upon the condition, you will apply logic, है ना? Always remember, in the case of prism, you will, depending upon the condition, you will apply your logic. Now suppose if I have a prism and let's say this is the light ray going, and this is the normal. So light ray goes like this, incident sets point this is the normal R2, this is R1, this is I, and let's say it comes out. Please remember, if it comes out grazing, what do you mean by grazing? Grazing means basically what? Do you remember grazing incidence?
Yes, sir.
Grazing
Yes,
incidence
sir.
was basically
90
when the
degree.
angle was approximately 90-degree, right? So similarly, in the case of grazing emergence, this emergent ray comes out and grazes along the surface. So can you see over here? E is approximately equal to, so at the condition of grazing emergence, E is approximately equal to 90-degree. We know this particular thing, the light ray was going from denser to rarer medium, right? This was air, this was mu, right? So can anyone tell me, if this angle is 90-degree, what will be the value of R2? What will be the value of R2? Will R2 be the critical angle?
Yeah.
Basically R2 will become what? The critical angle, and we know what is the critical angle, right?
Refractive index.
Hmm? So from here, R2 is equals to what? Sin inverse of 1 by mu. So sin R2 is basically 1 by mu. Can I write this? Guys, can I write this? Hello, people.
Yes, sir.
So depending upon this R2, we can calculate R1. R1 will be A minus sine inverse of R1, right? R2, which will be 1 by mu. Am I correct? And depending upon this R1, can we calculate I from the Snell's law equation? Can we do this, guys? Yes or no? So, guys, basically, whatever condition is given, accordingly, we'll manipulate the equations in such a way that whatever thing is, required can be obtained easily, right? The main thing is, if it is grazing emergence, then angle of emergence is 90 degree, and for that R2 will become theta c, right? And then after this, we'll follow the whole thing, right? Is this condition clear, guys?
Yes, sir.
Yes, sir.
Similarly, there is condition of grazing emergence as well. So in the condition of
Sir,
grazing
didn't we just do this?
huh? Oh, sorry, my bad. Incidence. Okay. So similarly, the condition of grazing incidence will be what? Can anyone tell me from the name itself?
Angle of incidence will be 90.
90 equals
Angle of incidence will be 90. So here the incident ray will be grazing along the surface, and then if it grazes like this, then angle of incidence is equals to 90. Okay, it will go something like this, where R1 will become what? R1 will become what?
critical angle.
Critical angle. So here I will be approximately 90 degree, and accordingly R1 will become the critical angle. And we know how to calculate the critical angle, right? Sine inverse of rarer upon denser. Yes or no?
Yes, sir.
By the way, please remember, whenever here in this particular case E is 90 degree, then I becomes minimum. Always remember this I which you will get, no, that will be the minimum possible value of I. Is it clear? And similarly, in this case, when angle of incidence is 90 degree, then R1 will be the critical angle, then R2 will be what? A minus theta c, and again I will be E will be equals to something. E will be equals to something. That something, whatever will come, always remember here this E will become minimum. So when this grazing condition occurs, the if suppose grazing incidence is there, then angle of emergence will become minimum. And if angle of this thing is there, then this angle of emergence is 90 degree, then angle of incidence will be minimum. Is this clear?
Yes, sir.
So these two conditions are pretty much clear. Now I have to tell you three more conditions. There is one condition of no emergence.
Total internal reflection, right?
Exactly. If we talk about condition of no emergence, that implies if there is a prism on which you have incidental light ray at certain angle, this light ray goes like this, but please remember, you don't want this light ray to emerge out, then only it can be condition of no emergence, right? Yes or no? Yes or no?
Yes, sir.
So for no emergence, can I say this particular thing R2 shall be greater than the,
Yes, sir.
can I say this particular thing? Hello?
Yes,
Yes,
sir.
sir.
Yes, sir.
So R2 should be greater than the critical angle. And थोड़ा सा एडवांस स्टफ है, एडवांस्ड कंडीशंस भी बोल देता हूँ, मतलब with this result, with this condition applied to all those equations and all, we no, we are directly writing the result. Suppose if the refractive index of this is mu and this is placed in air, right? So advanced conditions, I can write down this particular thing. The angle of prism should be greater than twice of critical angle. These are conditions. I'm not giving you the derivation. From this condition, we have derived this. I have the derivation. If you want, I can just click a picture of that particular thing and send it to you. है ना? Anyways, पता नहीं वो समझ में आएगा कि नहीं आएगा, but this is one condition. If the angle of a prism should be greater than twice of the critical angle, there is one more condition, which is mu should be greater than cosec of E by 2. So if you want to mug these up, mug these up. I'm not giving you the derivation. If you want, I can give. Although please remember, for no emergence, this is the basic condition which you know, right?
Yeah.
So in the
Hmm.
previous case, with after finding R2, you said that we could find E. Yeah. So do we use sine I by
Yeah, you
sorry
use this
sine E
equation.
by sine R2, that formula?
You use this one, Snell's law, this equation. 1 into sine E is
This
equals to
one.
mu into sine into R2. Where R2, you know, it is A minus theta 3.
Okay, sir.
So that's why I'm just giving you the conditions. These are the small, important conditions which happens in the case of a prism. I'm not giving you proof for this one. Let it be. Now, fourth condition is the condition of maximum deviation. Do you remember this function? Yes or no? Guys, do you remember this function which we just derive for delta and I? And if I
Yes.
say ki when is for what angle of incidence will delta be maximum or minimum, what will you apply? Which concept?
Maxima, minima.
Maxima, minima. But you can see the function itself is like way too big, sir. ये solve करते करते रात हो जाएगी. But don't worry, people have already done it for you. Always remember, maximum deviation occurs at two different points, two different conditions. First, and you have already, you know, we have already discussed those conditions. So basically, whenever someone talks ki at what angle will condition the deviation will be maximum, so the deviation becomes maximum when there is either grazing incidence or grazing emergence, right? So in this condition, I'll just copy paste. See, you need to draw this diagram again, obviously. Please remember, I already told you this particular thing. This E will be basically the minimum possible of value of E, and I will be basically the minimum possible value of I in this case, right? And here, when these two gets minimum and maximum, if I want to draw what is the angle of deviation, so can you see the incident ray is going like this? Yes or no? The emergent ray is going like this. So can you see this angle is basically the maximum deviation angle. Similarly, this light ray will go like this. This light ray will go like this. So can you see, guys, again? Sorry. This is the maximum. Guys, I think I made a mistake. Sorry. This angle is basically the maximum deviation angle. Okay? Because I told you, no, see, here the incident ray was going like this and the emergent ray was going like this. So the angle between both of them is basically what? The delta. Similarly, here this incident ray is going like this, emergent ray is going like this. So this will be your delta. So guys, can you see this particular thing? The value of delta will be maximum when either it will be grazing incidence or grazing emergence. Is this clear?
Yes,
Yes,
sir.
sir.
इतना लिख लो. Now the next derivation which I am going to give you is again a part of your syllabus. This maximum deviation is not there, but सिर्फ only the conditions are mentioned कि grazing incidence पे होता है, grazing emergence पे होता है. And don't worry, we'll do questions as well. है ना? If you have drawn this one, then let's move on to the last condition, which is basically the condition of minimum deviation. Again, I'll mention the condition. The minimum deviation occurs when the light ray becomes parallel to the base inside the prism. Okay, so when the light ray becomes parallel to the base inside the prism, at that condition delta will be minimum. Also, At this condition, angle of incidence and angle of emergence will be equal. Is it clear? I'll try to draw this for you. It's like this. Can you see this light ray which is there inside the prism? This light ray is parallel to the base. When this happens, then when this happens, guys, always remember this angle of incidence and angle of emergence will be equal. When we say they will be equal, even our R1 and R2 are also
Equal.
equal.
Hmm.
And if R1 and R2 are equal, then can I say this particular thing R1 plus R2 is basically A? If R1 and R2 are equals to R, then twice of R is equals to A and R is equals to A by 2. Can I say this?
Yes, sir.
So if I can say this, I can write directly over here. When R1 and R2 are equal to A by 2, then delta becomes delta min. So this angle is basically the minimum possible angle when this condition occurs. Is it clear? Guys, is it clear?
Yes, sir.
So by the formula, can we write the deviation angle formula? Anyone remember the deviation angle will be delta will be equals to I plus E minus A, right? Yes or no?
Yes, sir.
So can I write from here delta min if delta is basically delta minimum, then I and E will be equal to, I'm writing at I plus E will be twice of I minus E. Can I write it like this?
Yes, sir.
And from here, can I write I will be equals to delta minimum plus A by 2? Can I write it can I write it like this?
Yes, sir.
If I can write it like this, now by Snell's law, apply Snell's law on any one of the surface. Guys, can you apply Snell's law on any one of the surface? 1 into sine I is equals to mu into sine R1, and R1 is basically equals to what? A by 2, right? Right or wrong? So sine of I can write it as delta minimum plus A by 2. Sine R1 I can write it as sine of A by 2. This thing is equal to. So this is the formula for refractive index, and this derivation is there in your school syllabus. Although, can you see what do you need to remember? You need to remember these conditions, right? And you need to remember the three equations or four maybe. This delta one as well. That's it. And you need to rearrange again. Is it clear? So when mu is basically, if someone says कि derive mu in terms of the minimum deviation angle in case of a prism, then this derivation you need to do. Okay. Is it clear, guys? लिख लो प्लीज. So can you see over here in optics the derivations are easy, right? Although you need to do what? You need to apply a little bit of trigonometry and all. Guys, are you done?
Yes, sir.
No, question nahi. The last thing to be discussed in the prism is basically delta versus angle of incidence graph. And very important guys, it's मतलब स्कूल के सिलेबस में हमेशा ऑप्टिक्स में से ये क्वेश्चन आएगा ही. Always remember. So if I want to draw a graph, bit delta and angle of incidence. Okay, so the graph, it starts from I being the minimum and it goes like this. It's a shape of, just a Nike का वो होता है ना, Nike, or what is this, Nike right, no? Nike is the right one. ऐसा Nike किसका होता है? So it's in that shape, right? So please remember this particular thing. It's in shape like this. It's initially curved a little more and then it goes a little bit, lesser. The slope is less. Can you say there are 2 points? There is one point. Guys, can you see this one point where delta is basically maximum? Delta will be maximum at what value? 1 will be when I will be equals to minimum, and when I will be minimum, E will be 90 degree, if you remember. Yes?
So,
Yes, sir.
What condition is this? Grazing?
Emergence.
Emergence. And at this particular condition, I will be maximum,
That'll be grazing, right?
and that will be 90 degree. And here E will be become minimum. Acha, by the way, this is the maximum possible value of E max, right? E will be equals to E max, and that is equals to 90 degree. Is the first this part clear? Can you see at what points basically you are having maximum deviation? Now can you see over here there is one point at which the delta is minimum. This is the point where I and E are equal. Yes or no? Is this clear guys? Yes or no? ग्राफ समझ में आया
yes,
guys?
sir.
इतना पॉइंट समझ में आया? Now there are some additional points as well. For every value of delta between delta max and delta minimum. Although delta max has two values, delta max is basically occurring at two different values of I, right? Can you see the i's value is occurring at two different values? When I was minimum, then also delta was maximum, and when I was maximum, then also delta was maximum, right? So for every value of delta between delta max and delta min, there are two values of angle of incidences for which we get same delta, same value of deviation. So basically, suppose if I talk about any general delta, so can you see over here there is one point lying over here and one point lying over here? So suppose guys, this general value of delta is occurring at this particular angle of incidence. Let's say when I was equals to theta 1 and E is equals to theta 2, suppose. है ना? So this value will occur when the value of I is equals to theta 2 and E is equals to theta 1 according to the principle of reversibility. Okay, so there are two values of angle of incidence for which we get the same delta, but please remember, if I is theta 1, E is theta 2, then the next same value of delta will be there when I is theta 2 and E is theta 1. Is this clear?
Yes, sir.
Huh. So second point is, if we interchange value of angle of incidence and angle of emergence, we get again the same delta. And can you see, you guys, there is only one angle. There is only one angle at which the deviation is minimum. Third point you can write for this as well. Only one angle exists for delta to be. Is this clear? Please write. And give me 2 minutes, I'll be back. Yes, guys, done. Everyone done? This graph is what we have drawn for that function which we wrote now. Delta is equals to f of I. The graph is for that. Anyways, next heading, thin prisms. If the prisms will be small, basically what will happen? If a prism is like this, guys, can you hear me?
Yes, sir.
Yes, sir.
If the prism is like this, is it a thin frame? Thin prism? It means basically what? The distance between the refracting surfaces is very low. If the distance between the refracting surface is very low, can you see the angle of prism? The angle of prism will also be very low. Small. If angle of prism will be small, then can I say this particular thing? Hello guys. A is basically equals to R1 plus R2. If A is tending to 0, if A is very small, then can I say R1 and R2 will be also very small? Yes or no? And if I1, R1 and R2 will be very small, then by default I and E will also become small, right? So basically for thin prisms, can we apply the small angle approximations? Are basically special case.
Yes, sir.
So
Yes,
by
sir.
Snell's law, we know this particular thing already. I'm not drawing the whole diagram, obviously. 1 into sine I is equals to mu into sine E. Can I write this? This is the first equation. नहीं एक सेकंड कुछ गड़बड़ करेंगे हाँ mu into sine r1. Yes or no? And similarly 1 into sine E will be equals to mu into sine of r2, right? Yes or no? So we know this particular thing. If the angles are small, then I will be approximated to I in radians. So sine I will be like this, sine r1 will be like this, mu will be like this. So can you see I is equals to mu into r1? And similarly, E will be equals to mu into r2. Yes or no?
Yes, sir.
So similarly, what will be the value of delta? Delta is basically I plus E minus A, right? Yes or no? Can I write it as I plus E minus R1 minus R2 like this, right? And similarly, can I write it over here I minus R1 plus E minus R2, just like from where we derived the delta thing. I'm writing the basic one, right? So can you see R1 will be equals to I upon mu. So I into 1 minus 1 upon mu. R1 ko I have written what? I upon mu, and I have taken I as common, right? Yes or no? Or in spite of doing that, let's do this. I ko as it is. I ko I have I ko let's write it as mu into R1 minus R1 plus I ko E ko we can write it as mu into R2 minus R2. So can you see over here from here R1 into mu minus 1 plus here it will be R2 into mu minus 1. Yes or no? And now can I take mu minus 1 common? And what will be left? Only R1 plus R2 will be left, and this will be mu minus 1. So can you see this is basically what? The angle of prism. So in the case of thin prisms, we'll be using this formula. Please write. And with this thing, I'm done with your prism thing. Okay. Now after this, we'll discuss certain questions. 2-4 questions we'll do, and we'll discuss the refraction from single spherical surface. That's what I have planned for today. Guys, whenever you're done with the this thing, tell. Guys, are you done?
Yes, sir.
First question. Can you see the figure, guys? In this figure, there is a prism given to you, and they have said this is a right-angled prism. What do you mean by right-angled prism? That the angle of prism is basically 90 degree, right? Okay. Now the question is find the angle of incidence if the light ray if the light ray find the angle of if find the angle of incidence of the light ray on face AB of prism such that light will reach face AC at an incidence angle equal to 60 degrees. So basically you want the light ray to reach on face AC in such a way that the angle of incidence should be how much? On face AC should be 60 degree. And for this you need to find out what is this. Now in my question, guys, you understood the question? Guys, did you understand the question? Only one liner question, not big of deal. कैसे करेंगे? We know this particular thing that the angle of prism is basically sum of this angle and this angle, right? So this angle is 60 degree. What will be this angle? This angle will become 30 degree. And if this angle becomes 30 degree, acha, they have given the refractive index is 2. They have given this in the question. The refractive index is 2. So by Snell's law, yes, who will apply Snell's law over here? Navina, can you tell me if you apply Snell's law over here, what will be the equation?
Yes, sir. So for the base AB, yeah.
Hmm.
Okay. So it will be 1 second, sir. So it will be 1 into sine I equal to 2 into sine 30.
Correct. So from here, sin I will be equals to twice of 1 by 2 cut, and hence from here sin I equals to 1, and hence I will be basically it's a case of phasing. Is it clear? So see, one liner question only. You need to just remember some things, and automatically your answer will come. Do this, and we'll do the next question. Yes, guys. What do you mean by this? What do you mean by an equilateral prism? What do you mean by an equilateral prism?
All the sides are equal.
Angles
Angle will be 60.
60 degrees. The angle
Yeah,
of prism will
angle.
be 60 degrees. For which light will suffer minimum deviation. Also, find this minimum deviation angle.
So I think Ovia got disconnected. Can you let her in?
Yes, I did. Yes, tell me. एक सेकंड, थोड़ा सा जोर से बोलो बेटा. Can you please speak a little bit louder?
Sir, can you hear me?
Yes, I can hear you now.
So, normal should be perpendicular to the surface, right?
Correct.
So that means how can I be 90? That means shouldn't it be along the surface?
Nah, beta, angle of I is 90. That implies this which I have drawn. No, it's like
That should
this.
be along this
Yes,
line,
it is
right?
along the surface. If it
Okay.
will, it is like this. Okay.
Okay, sir.
So this angle becomes 90 degrees. Anyways, next. So guys, what is given to you? Only two things are given to you. Angle of prism is 60 degree and mu is root 2. And they are asking you to find out the angle of incidence. But we know this particular thing. They have mentioned minimum deviation. So we have further more condition. At minimum deviation, I and E will be equal. R1 and R2 will be equals to A by 2. And A is given to you. So that implies this is 30 degree. If this is 30 degree, you can find out I and E as well. कर सकते हो? So by Snell's law, 1 into sin I is equals to mu into sin R. So sin I will be equals to root 2 times of sine of 30. Sine of 30 is, yes or no? तो ये कटेगा, एक root 2 बच जाएगा. And can you see from here I will be equals to 45. If I will be equals to 45, then this is also known to us now. Yes or no? Yes or no? And we also know this thing, delta minimum is basically I plus E minus A. So 45 plus 45 minus A, 60 degree. So 30, and that's the answer. and this is the answer. Easy? Guys, is it easy?
Yes, sir.
Hmm. Chalo, one more question. Please remember, question में क्या दिया? Equilateral prism. So angle
A is
is
equal to
60.
60.
Hmm. शुरू हो जाए. Done. A is 60 degree, and according to the question, the deviation is 40 degree. So can you see over here, deviation is basically I plus E minus A. Yes? Yes or no? So delta is 40 plus A is 60 is basically I plus E. So can you see from here the sum of the two angles is 100, and they have said in this particular thing the difference of the two angles is basically 20. So can you suggest me two angles for which uh, you know the sum will be to 100 and the difference will be 20?
1640.
60 and 40.
Next. Guys, ये clear है क्या?
Yes, sir.
Please write down next heading. Refraction at single spherical surface. Okay. So you need to find out the refraction at a single spherical surface. So suppose you have a surface like this. Okay, let's say this is the principal axis of the whole thing, and let's say here there is a medium 1 which has a medium refractive index mu 1, and on this side, this side, this sphere, this spherical surface, guys, is of medium 2. Is it clear? This is basically the pole, and let us assume there is an object which is at a distance of u. Is it clear? इतना clear है, guys?
Yes, sir.
Yes, sir.
Okay. Let us say the center of curvature of the surface is over here, and if I try to draw the normal, and let's say if the incident ray is drawn, let me draw the incident ray. So there is one incident ray like this. Please remember these angles are very small. For just representation purposes, I'm drawing it a little bit big. Otherwise, this point would have fallen over somewhere over here. It's near normal incidence, paraxial cases, if you remember. So this is one of the incident ray, and another incident ray is like this. So can you see this will just pass as it is without any deflection, right? So these are your two incident rays, and let's say this light ray is falling at a point B. Okay, is it clear, guys? If I try to draw a normal, so how will the normal look like, guys? Will the normal look like this, the one which is passing through the center? Will the normal to at this particular point, will it look like passing through this particular point? Yes or no? The center?
Yes, sir.
And if I say medium 1 is, let's say, rarer and medium 2 is denser, so will it bend towards the normal or away from the normal? Towards the normal, or जो भी है, मतलब जैसा भी है, I don't know whether it is towards the normal or away from the normal. For derivation purposes, I am assuming that the image, let's say, it forms somewhere over here. Let's say the image forms over here. This is one of the refracted ray. This is also one of the refracted ray. Can you see the refracted rays are actually meeting? So hence the image is real. Real object, real image, right? I'm taking this as my example. From here, I'll proceed. Is it fine? Now, first thing first, do you remember this thing is exactly same as spherical mirrors? I'll drop a perpendicular from B at point P dash. Everyone can see the perpendicular, right? Now,
Yes,
since if I say the angle made by the object, this angle is alpha, this is beta, and this is gamma. Do you remember alpha, beta, and gamma? Alpha was basically the angle made by the object, beta was basically the angle made by the normal, and gamma was basically the angle made by, right? Yes or no, people?
Yes, sir.
This angle is angle of incidence, and this angle is angle of refraction. Yes? Yes or no, guys?
Yes,
Yes.
sir.
Now, can you see this particular thing by Snell's law? Can you apply Snell's law over here at this particular point on this surface? Can I write mu1 multiplied by sine of I is equals to mu2 multiplied by sine of r? Can I say this?
Yes, sir.
Okay. Now see this particular thing, guys. For paraxial rays, if I say for near normal incidence or paraxial rays, जितने भी एंगल बनेंगे यहाँ पे, अल्फा, बीटा, गामा, आई, आर, all these angles will be small. Yes, will they be small? If all of
Yes,
these
sir.
angles will
Yes,
be
sir.
small, then can I write mu1 into I is equals to mu2 into r? This will be our equation
Yeah.
number 1. इतना clear सबको?
Yes, sir.
Okay. Now see this particular thing, guys. This distance from here to P to C. What is the distance from P to C? This is basically the radius of curvature, and PR to the I is basically the image distance, right?
Sir,
Huh?
sir, if can we interchange beta and gamma,
No,
or is
no,
it
no.
false?
Never ever do it. That's why I'm telling you that alpha is for object, beta is for normal, and gamma was for image.
Okay, sir.
Okay?
No, because in school we did it the other way. Took beta for the image. That's why I
No
asked.
problem. ऐसा generally, this is the convention which I have set. Your school teacher is following a different convention. No problem. If you want, I can change this. No problem. I don't have any issues. I am very flexible.
So can we change or is it fixed?
हाँ ठीक लो इसको क्या कर दूं मैं इसको गामा कर देता हूँ एंड लेट्स से इसको मैं बीटा कर देता हूँ ओके
Okay, sir.
so this is beta and let's say this is gamma. It doesn't matter. So is first equation clear to you, I and R? Is there any doubt? Now since point B close to P, hence P and P dash will also lie very close to each other. Since it's near normal incidence, so B will be lying close to P, right? So can I say all the distances from P can be measured from P dash as well? Can I say this particular thing? OP is equals to OP dash approximately. IP is equals to IP dash. And CP is equals to CP dash. Yes or no? Now you may be seeing three triangles very carefully. One is this triangle, triangle OBP dash. This angle was alpha, right? You might be seeing this triangle BP dash, and this is, let's say, C. And you said, sir, take it as gamma. I take it as gamma. And there is one more, IP dash and B. And this angle is beta, right? Yes or no?
Yes, sir.
So now can you see from here tan alpha will be equals to, guys, tan alpha will be equals to BP
BP
dash
dash by
upon
OP dash.
OP dash,
Okay.
right?
Yes,
And
sir.
can I write this
Yes, sir.
P dash as P because they are very close to each other? Can I say this thing as BP upon OP? Can I write
Hmm.
this? Similarly,
Yes, sir.
similarly, this will be written as
BP dash by P dash C.
CP dash or CP approximate. And oh sorry, सही है. Tan beta will be equals to what?
BP dash
BP
by
dash
Dash
upon
by P
IP
dash I.
dash. So BP upon IP. इतना सबको क्लियर है. I guess this much is pretty much clear to everyone, right?
Yes.
अब थोड़ा सा ट्रिग्नोमेट्री और देखेंगे. Let's see a little bit more triangles. Can you see over here? This triangle BCI. In triangle BCI, have everyone drawn the diagram? Has everyone drawn the diagram?
Yeah.
Yes, sir.
So I'll try to draw the diagram again for you. B. So it looks like this. Okay. This angle is what? This angle was beta, and if you remember, this angle was gamma, right? I'll show this again to you.
Yes, sir.
Can you see this angle is gamma and this angle was beta, BCI. And can you see this angle is R? Yes. So this angle is R. Now, if this is gamma, so this will be pi minus gamma. And can you see over here, pi minus gamma plus R plus beta will be equals to what? 180 degree. And from here, gamma will be equals to R plus beta. Yes or no? Yes or no, guys?
Yes, sir.
Okay.
Yes, sir.
Similarly, in another triangle, BOC. BOC. Can everyone see over here? This OB and this normal were basically the angle of incidence, right? BC was basically the normal, right? So this angle was I. This is alpha and this is 90 degree. Oh, sorry. This is alpha and this is gamma. So this is gamma and this is alpha. Similarly, the same concept. Can I apply it over here as well? So pi minus I plus alpha plus gamma is equals to 0. So from here, can I say I will be equals to alpha plus gamma? Can I say this?
Yes.
Sir.
है ना? अब I is basically equals to alpha plus gamma. R from here, can I write R is equals to beta minus gamma minus beta?
Yes, sir.
So can I put these two things? Let me name them as equation number 2 and 3. Let's say this is 2 and this is 2. So by substituting the value of I and R in equation 1. And what was equation 1? Mu1 into I is equals to mu2 into R. So can I write this particular thing? Mu1 into I. I is alpha plus gamma is equals to mu2. R is gamma minus beta, right?
Beta.
So can I write this as mu1 alpha plus mu1 gamma is equals to mu2 gamma minus mu2 beta? Yes or no? Yes or no? Can I take the gamma terms on one side and alpha beta on other side?
Yeah.
So mu1 into alpha plus mu2 into beta is equals to mu2 minus mu1 into. Can I do this?
Yeah.
Now we know this particular thing कि even alpha, beta and gamma were small. So alpha can be approximated to tan alpha. Beta can be, I'll do this approximation over here only. Let's say here. So since alpha was small, so tan alpha will be substituted by this. This is gamma and this is beta. Since alpha, beta and gamma were small, right? So tan alpha is approximated to this only. Yes or no? So wherever there is alpha, I'll write BP upon OP. So mu1 into BP upon OP plus mu2. Wherever there is beta, I'll write that is beta. Wherever there is beta, I'll write BP upon IP. So BP upon IP is equals to mu2 minus mu1 and this will be BP upon CP, right?
Yeah.
by small angle approximations. Please remember this equation. From where does it come? By small angles of approximation, alpha, beta, gamma was small. So now, can you see BP, BP and BP will get cancelled out. So it will be mu1 upon OP plus mu2 upon IP is equals to mu2 minus mu1 upon CP. Yes or no? Now, once you have derived this, then using sign conventions. Sir, why are we applying sign conventions? So that we can generalize this derivation for every type of situation, right? So that is why we are applying sign conventions over here. Do you remember this particular thing? Can you see OP is minus of U? Can you see towards the left? I am choosing this convention, right? सुबह आया था सुबह आया था तो positive and CP, can you see CP is towards right, so CP will be plus R and IP will be
Plus V.
plus V. So can I use this convention? Shall I copy and paste? So shall I use this convention over here? So mu1 divided by minus of U plus mu2 divided by plus of V is equals to mu2 minus mu1 divided by plus of R. From here, you will get mu2 by V minus mu1 by U is equals to mu2 minus mu1 by R. This is the formula for your refraction to single surfaces. Is this clear? Guys, this is clear. Plus, please remember, note, use this formula with sign conventions for any case. Why will you use the sign
Even though we
convention?
use sign convention in deriving it?
What? Yes.
Even though we use sign convention in deriving it?
When you are deriving it, you are generalizing, you are making it specific for only one case, right? So by using the sign convention, you make it generalized for all. यहाँ से these conventions which we have used were specific to what case? When the image is forming towards right, the center of curvature is towards right, so it was specific to that case only. So basically, by using the sign convention to a specific case, we generalized it for the whole thing. We made a generalized formula. ये और फिर ये generalized formula को if I want to use in every case, then I have to use those sign conventions again.
Okay.
So इसलिए दो बार साइन कन्वेंशन का इस्तेमाल होता है, एक बार फॉर्मूला डिराइव करने में और एक बार यूज करने में. अब when I'll be deriving the formula for lens maker, I'll not be putting this sign convention again. Ask me why. अच्छा चलो मैं वो तब का तब रीजन बताऊंगा, no problem. So is this clear, guys?
Yes, sir.
ठीक. So in the next class I'll be giving you numericals based on this, and we'll be done with this part and we'll start with lenses. Okay?
Okay, sir. Yeah.
So in 2 or 3 classes, this lenses will be over as well, and we'll start with optical instrument and ray optics will get over. ठीक है?
Yes, sir.
ठीक है. चलिए guys, thank you very much. We'll see you again in the next class, and don't worry about the JE part. First, I'm trying to, मैंने थोड़ी सी deadline बनाई थी. I made a deadline like 1 complete month will be used for optics and 1 complete month will be used for modern physics. ठीक है? So
Okay, sir.
I'll try to cover the remaining portion of this ray optics later on in December when everything will be finished, or maybe in Jan. है ना, जब भी मतलब तुम्हारे पेपर से पहले हो जाएगी. ठीक है? But till that time, let me finish off with the remaining. ठीक है?
Yes, sir.
चलिए guys, thank you very much. We'll see you again.
Thank you, sir.
Yes, sir.
Thank you, sir.
Okay.